So this is the quiz review for conditional probability. Question 1. Steph has 12 different shirts, 7 pairs of pants, and 7 pairs of shoes. How many different outfits can she create? So you're going to multiply the 12 shirts times 7 pairs of pants times 7 pairs of shoes. And when you do that on your calculator, you get 588 different outfits. Hold on, I'm just going to adjust the camera for a minute so I can get the whole paper. There we go. In a 7-digit phone number, the first 3 digits represent the exchange. If within a particular area code there are 53 exchanges, how many phone numbers can be made? So it's 7 digits. The first 3 have 53 exchanges. So we're just going to use that for the first 3 digits, 53. Then there are 4 more digits, and they can repeat. So there are 10 digits, 0 through 9. So we're going to multiply by 10, by 10, by 10, and by 10. So there are 53 different possibilities for the first 3. So we already have that. And then the next 4 digits, we multiply. So there's 10 possibilities for each digit. So you multiply by 10, by 10, by 10, by 10. And when you do that out, you get 530,000 different phone numbers. Always good to put a box around your answer. There we go. Now it's all in there. All right, number 3. In how many different ways can somebody answer all of the questions on a true or false test consisting of 20 questions, assuming they don't leave a question blank? So if it's true or false, there are 2 possibilities for each question, true or false. So there's 2 possibilities, and then there's for each question, there's 20 questions. Now, instead of writing 2 times 2 times 2 times 2 20 times, you can do 2 to the 20th power. When you put that in on your calculator, you're going to get 1,048,576 different ways. Number 4. I see the camera keeps trying to get that way. Okay, number 4. A restaurant has 5 appetizers, 8 beverages, 9 entrees, and 6 desserts on the menu. How many possible combinations of meals are there, assuming you choose one from each choice? So you have 5 appetizers times 8 beverages times 9 different entrees times 6 desserts. When you enter that in your calculator, you should get 2,160 different meal combinations. On to number 5. It says you draw a random card out of a standard deck of cards. What is the probability that the card is a face card or a spade? Write your answer as a fraction in simplest form, a decimal rounded to the nearest hundredth, and a percent rounded to the nearest whole number. So we want the probability that it is a face card or a spade. So there are, if you need to pull up the deck of cards on Classroom, you can do that and look at that. To do this, so there are 12 face cards out of 52. Plus, how many spades are there is going to be 13 spades out of 52. Then you need to subtract the face cards that are spades which there's 3 of them. So when you do that, you're going to get 22 over 52. You can simplify that by dividing both of them by 2. So you get 11 over 26. And that can't be simplified anymore. So that's your fraction in simplest form. Now you need to put it in a decimal. So you do 11 divided by 26. And that's about 0.42. And then when you put that into a percentage, you move the decimal 2 places to the right, so it's 42%. About 42%. And those are your 3 answers. Number 6. You draw 3 random cards out of a standard deck of cards without replacement. So that's important. Without replacement. What is the probability of getting 3 aces? Write your answer as a fraction in simplest form, a decimal rounded to the nearest hundredth, and a percent rounded to the nearest whole number. A decimal rounded to the nearest hundredth means there are 2 decimal places. So a standard deck card. So we need probability of getting 3 aces. So you have the deck of cards. The chances of getting ace the first time you pick a card is 13. Hold on, I'm just making sure I read this right. Okay, sorry about that. There was an interruption. So, all right, so the probability of getting 3 aces. So the first time you pick out of the deck of cards, your chances of getting an ace would be there are 4 aces out of 52 cards. Now I'm not replacing the cards, so now you're going to multiply that. The chances of you getting an ace the second time, you have to assume you got one the first time, so there's only 3 aces left, and there's only 51 cards left because you didn't put that card back. So then you would do the second time. There's 2 aces left, and there's 50 cards. We did this problem in class, too. So now you're going to multiply the numbers. I'm just going to do that in my calculator. For 24 over 153. I'm just seeing if you can simplify that. Okay, so if you divide each by 3, that will give you 8 over 51. So that's the answer as a fraction. Then if you do 8 divided by 51, you get about 0.16 because it said to round to the nearest hundredth, so I'll do that. And then that as a percentage would be 16%. And those are your answers. Number 7. A fair coin is tossed 3 times. A fair coin just means one side is heads and one side is tails. It's not a trick coin. A fair coin is tossed 3 times. What is the probability of getting heads on the first toss and then tails on the next 2 tosses? Write your answer as a fraction, decimal, and percent. So you want probability of getting heads, tails, tails. And then you want to do it's 1/2 times 1/2 times 1/2 because you have a 1 out of 2 chance of getting either heads or tails. So when you multiply those, it comes out to 1/8. That's the fraction. When you do 1 divided by 8 on the calculator, you're going to get about 0.13. And when you write that as a percentage, it's going to be 13%. Now, when you're doing the rounding, When you do this on the calculator, 1 divided by 8, you're going to get 0.125, but because we're rounding to the nearest hundredth, because this is a 5, you make the 2 a 3 when you round. Okay, next page. 8. A fair die is rolled. What is the probability of rolling a number that is odd or less than 5? Write your answer as a fraction, decimal, and percent. So we want the probability that it is odd or less than 5. So when a die has one, let's write the numbers that are on the die. A die is 1 dice, by the way. So that's 1. You can get a 2, you could get a 3, 4, a 5, or a 6. So of those digits, so 1 is odd. It's also less than 5. 2 is even, but it's less than 5. So that's a possibility. 3 is odd. 4 is even, but it's less than 5. So that's a possibility. And then 5 is odd. So that would count. It's not less than 5, but it's odd. So you would count that. So you have, out of the 6 sides of the die, 5 of them would fit this, odd or less than 5. So that is 5/6, 5 out of 6. That's already simplified. So then when you do that on the calculator, 5 divided by, I'm sorry, my paper keeps turning. I don't know. The camera keeps doing that. Oh, why? Okay, so 5 divided by 6 is 0.83 repeat. So that'd be, I'll put 0.83, and then that's about 83%. If you think about it, it makes sense because it's pretty good chances that you're going to get either a 5 or less if you roll a die. So those are your 3 answers. Number 9, a jar contains 3 red marbles, 7 green marbles, and 10 white marbles. If 2 marbles are drawn from the jar at random without replacement, that's important. What is the probability that the first marble is white and the second marble is red? Write your answer as a fraction, decimal, and percent. So we want the probability that it's white and then red. So you need to look how many white marbles are there. 10 over how many total marbles? 3 plus 7 plus 10 is 20. And then you multiply that by, so you didn't replace the marbles, so now you only have 19 marbles when you pick the second one. And red, there are 3, so it's 3 over 19. So when you multiply those, you're going to get 30 over 380, which you can divide both of those by 10 to simplify, so you get 3 over 38. That's your answer as a fraction. When you do that, 3 divided by 38 on your calculator, you get the decimal, 0.08. And then that is about 8%, because when you do the percent, you just move the decimal 2 places to the right. And those are the 3 answers for that. Fix this. There we go. The camera was messed up. Okay, here we go. So now the table below shows the favorite subject of different students. Write all your answers as percent rounded to the nearest tenth. Write all answers as percents rounded to the nearest tenth. That is 1 decimal place. So it says, what percent of all students are 9th graders that prefer history? So we have what percent of all students? So we need the total number of students in the denominator. So that's 200. And we need 9th graders that prefer history. So that is 33. So when you do 33 divided by 200 on your calculator, you're going to get 0.165. So you move the decimal 2 places to the right, 16.5% is the answer for that one. What percent of 10th graders prefer English? So on this one, you have 10th graders. So the total number of 10th graders is 101. That's our denominator. 10th graders that prefer English is here, 27. 27 over 101. When you do that, you're going to get about 0.267, which would then be about 26.7%. And then for C, what percent of students that prefer math? So the total number of students that prefer math is 84. That's our denominator. In the numerator, you have to put the number of 9th graders that prefer math, so that's 40. So when you do 40 divided by 84 in your calculator, you're going to get about 0. Hold on, let me do it on my calculator. 40 divided by 84. 4761. So then when you put that as a percentage, move the decimal point 2 places to the right, and so that will give you 47.6%. And that is your answer. And that's the practice quiz. Have a good day.